Welcome back. Let's start the second part of the second day. And let's delve into the topic of measurement as an architectural concern with Eoin Woods, the CTO of Endava. In his role, he is accountable for capability development, innovation, and emerging technologies. He's a frequent conference speaker, co-author of 3 influential books on software architecture, and was honored with the 2018 Northrop Award for Software Architecture from the Software Engineering Institute at CMU. It is an absolute honor to have you here with us, and welcome to the stage.
Good afternoon, Global Software Architecture Summit. It's just after lunch. Did you have a nice lunch? Are you all awake? So we'll have to work together because it's the after lunch slot. I'll be as engaging as I can be without falling asleep. You'll be as responsive as you can be without falling asleep. How about that? Is that a deal? And we'll get through 45 minutes together. Great. Once again, thank you to our sponsors. We all wouldn't be here because there'd be huge amounts of money missing if it wasn't for the sponsors. Thank you very much to all of them who've made a big contribution to us. My name is Eoin Woods. I realize if you don't know me, that's not entirely obvious unless you're from Ireland. It's an Irish name. Don't pronounce the E. Pronounce the rest in English. That's pretty close. I do work for Endava. I'm actually chief engineer now. I've been there since 2015. It seems like yesterday. Before Endava, I worked quite a lot in product development, including a spell in California. Then I came back to London. I worked in the capital markets industry for big banks, especially UBS. And then I joined Endava, which has been terrific. And I've always been a software person. So that's kind of what I do. I haven't arrived from some other industry. So that's a strength and a limitation, I guess. So I'm going to talk to you a bit about measurement in software systems, which, when I came to think about this about a year ago, I thought, everyone knows about measurement in software systems. And then I found, actually, I couldn't find very much about measurement in software systems beyond system monitoring, which, of course, is part of the puzzle, but is only part of it. So I thought, that's interesting. And I started digging, and I found I had lots of bits, but I didn't really know how to put it together. The thing is, how many people here have been told that you should get more feedback in your software development cycle? Like just about everyone. Agile people tell you, don't they? DevOps people, very, very keen on it. People, annoying people like me who talk about continuous architecture, we're always banging on about feedback loops. You just want us to shut up, really. And even things like Dave Farley's Modern Software Engineering talks a lot about feedback loops. So we talked a lot about you should have a feedback loop. How often have people said, and here's how you do it? Considerably less, I would say. And the reason I know that is because I give a talk on continuous architecture quite a lot. There's 5 key practices, which I won't bore you with, but the 5th one is create feedback loops. And it dawned on me, having done the talk half a dozen times, I'd got a lot to say on all the others, and I got to feedback loops, and I went, feedback loops, you should definitely have them. I got a bit better the second time I did it. I had 2 sentences, but I realized we just have less to say about it. So implementing feedback loops is not something we've talked about very much. Feedback is inherently about measurement, and I think this is one of the reasons we talk in the abstract about feedback loops. They're really terrific. You should always have one. Maybe you should have multiple of them. But actually, we often have to measure many kinds of things to achieve effective feedback, and we don't really discuss how to make those measurements. And what I have observed, seeing the privilege of seeing quite a lot of software projects now in my day job, is it can actually be quite complicated to do measurement. And if you haven't got the measurement, or if you don't know how to do the measurement at scale, feedback loops are really difficult to do. So I started off saying, well, let's start with the basics. We're engineers. We do like a good definition. What is measurement? And I don't know if you knew, but there's a whole science of measurement. It's called metrology. And there are metrological engineers who measure things. Not so much in software, unfortunately. A lot of them are involved in 3D shapes. If you think of 3D shapes for building bridges or space shuttles, actually measuring the 3D shape very accurately is very difficult. I will not digress any further, but it's quite an interesting field. What they say is it's about experimentally obtaining what they call quantity values for a quantity. And the quantity is the definition of what you want to measure, and a quantity value is all of the measurements of it. But then I came across Douglas Hubbard. How many of you read the book How to Measure Anything? quite big in business circles. A lot of enterprise architects I know have read it. Not very many people in software. Anyway, a software person, a guy called Pete Eels, who worked for IBM for many, many years, has just retired, put me onto it because he heard I was interested in measurement. And he's got a slightly different view of it, but a very interesting one. He says it's a quantitatively expressed reduction in uncertainty, which is kind of interesting, isn't it? The metrologists don't tell you what the measurement's for. Hubbard's quite clear. If you're not reducing uncertainty, it's probably not a useful measurement. And then Wikipedia looks like they've translated the metrologist's view into English. So it's much the same. It's the fact that it's a quantification of some attributes of an object or event. So that got me thinking as well. There's at least 2 views in the world, and there's probably half a dozen more, as to what measurement really is. But it's clearly about somehow quantifying attributes of things we're interested in. And then I kept tripping over the fact that people talk about metrics a lot, and some people talk about measurement. And it's worth just being clear. A metric, when you go to look it up, it's the definition of what is to be measured, such as CPU usage. A measurement is the result, or sometimes we mean the process, of actually getting a value for a metric. And I think this causes quite a lot of confusion when people talk about measurement, because they talk about, have you got any metrics? And you often don't know if they mean, do you know what you're measuring, or have you got accurate data for what you're measuring? So that's sort of the terminology that I came across, which was quite interesting because I realized I'd been using it quite informally for many years. And then, of course, the next thing I tripped across was system monitoring and observability. One point to be clear about, I'm not stepping into the monitoring versus observability debate. There's quite a heated debate going on. You have probably been observing as to whether system monitoring with its different aspects is really observability, or whether observability, you've got to start again and it's a different thing. For this talk, that's not relevant. The point is, I realized after some time that the monitoring observability people are creating quite a lot of data. But actually, for measurement, for feedback loops, we also need data, but they're for different purposes, which might actually mean that the monitoring and observability systems have to be used in a certain way. The reason is for measurement, we're making observations of our system, but also normally the development environment. So that could be other instances of the system, and also how we're behaving, in order to establish if we're heading towards a goal or not. As in, is our velocity increasing? Is our architectural structure improving? Is our performance getting better or getting worse? The monitoring observability people, for the most part, they're trying to work out, is the system working or not? Is it working in a normal state? And if it's not, what's wrong, so we can get it back? So I realized that actually, having chased the whole monitoring and observability thing quite a lot, I realized that most of what goes on in that world can provide useful input for measurement, but actually, they've got different goals. What they're working at is the system in a normal state or not, and how do we remediate it? Whereas measurement, we're trying to work out, are we going to hit a goal? So hopefully I've convinced you that measurement might be worth consideration. Well, why don't we just do it? And I observe lots of teams do just do it. And to start off, creating your first feedback loop is not very difficult, is it? You need to measure 2 or 3 things. You can probably get the data from one place, maybe, at the most 2, and there's not a lot of it, and it's all probably quite informal at that stage, so you can feedback quite quickly, and that's all fine. But what I found was that actually, the further you look into it, there's a lot of kinds of feedback that people are interested in. And there's a lot of techniques and data sources, which when further I looked across teams, I realized they're using some or all or none of these to create their feedback loops. And I think that's often where the problem is that it's not clear how these bits fit together. And that immediately, to me, made me think, this sounds a bit like an architecture problem. There's a somewhat undefined problem. There's lots of bits of stuff that might be useful in solving it, and we're not quite sure what the problem is, and we're not quite sure how to put the bits together. That pretty well describes my architecture work across quite a lot of my career, and probably yours as well. So perhaps being measurable is a quality of a system. It's a quality attribute. And if we thought about it like a quality attribute, that might give us a bit of a mental model for how to go about making systems measurable and how to make sense of all the things we're being asked to do and all the things that we might have to integrate together. Because as soon as I started researching this, when I started it, of course, I came in with a particular mindset and a whole lot of assumptions. If you look at those things you could measure on the board, I'm pretty certain as soon as you look at one of them, you'll immediately think of 6 more that aren't on the board. There's an incredible amount of stuff we can measure. And I think in many projects, that's one of the first problems. We could measure a lot of stuff. It's not clear how much we should measure, but we do end up measuring many different things, and actually, it's not quite clear how we manage that. Because we've got lots of things that can be used to measure our software systems. And as soon as you glance at this, you realize I've probably missed whole swathes of it. There's nothing in here about user behavior measurement, for example. It's all the more technical end, because to be honest, I got this many logos on the screen, and I thought, I think I've made a point. Let's move on. Life's too short. But there's all kinds of other sources of measurement as well. So it all ends up being, I've observed, a bit complicated and a bit ad hoc and a bit of a rat's nest, because we've been asked to measure lots of different things for different people, lots of different kinds of feedback loop, and we didn't have any framework in our heads for how all this fitted together. So we end up with lots of pieces. So it's a bit like the network diagram. We just get lots of point-to-point links, extracting data and shoving it somewhere. The best defined bit is normally system monitoring. But that, as we saw from our metrics, that's only one kind of feedback loop, and it only answers a small subset of the questions that many software architects are asked about. So if we applied a bit of architectural thinking to this possibly confused environment, what would we bring to it? Well, the 4 things that I immediately think of: 1, we love creating models and frameworks, so we could organize it for people. Secondly, we're pretty good with trade-offs. Measurement isn't free, and measurement can add complexity, it can add runtime overhead, it can add long-term costs. It can make us less agile because of the mechanisms we've got, so we're good at trade-offs. We have architectural tactics. So you'll be aware that a tactic is anything architects use to solve a problem. So principles, techniques, mechanisms. We could assemble some tactics which have proven to be useful, and they could be repeated over different projects. And finally, there's nobody like an architect to tell you what's going to go wrong. So we could bring pitfalls, because we kind of know about pitfalls. We've all fallen down enough potholes that we know what to look for. So that's the kind of stuff I thought, this could actually be quite beneficial to think about this as an architecture problem. So what would measurement look like as an architectural concern? Well, as I say, there's 4 things I think that we think about. There's the architectural concerns. That basically defines why do we care, and ideally who cares. Then there's the tactics. So that's what are we going to do to address those architectural concerns. Then ideal activities, because if we just give people a load of stuff to do without any guidance when to do it or how to do it, that's probably just going to be confusing. So perhaps we could explain to people how to go about it. And finally, we could catalog all the things we know are probably going to go wrong to someone at some point, and they could be a very useful guide to not having them happen to your project. As an aside, this structure concerns tactics, activities, and pitfalls. It's a structured way of sharing architecture knowledge, architecture wisdom, if you like, for quality attributes. And it's called an architecture perspective. And if you're interested in more about it, there is a website, viewpointsandperspectives.info, which in the interest of full disclosure, I would have to say, I'm the co-owner of. It came from the original software systems architecture book. So what are the architectural concerns for measurement? I realized actually they weren't very complicated. This was the easiest part of the problem. What are you going to measure? So who wants to know? What do they want to know? And why do they want to know it? That's quite straightforward. That's not a difficult concern at all. Then there's how to measure it. And actually that got quite a bit more difficult quite quickly. How do you measure something with acceptable accuracy? What is accuracy and what is acceptable? You all know the answer now, don't you? We've been saying it for 2 days. It depends. Yeah, well done. Yeah. Acceptable concurrency, acceptable runtime cost, acceptable long-term cost. All of these things need to be understood and qualified so that we don't put a kind of great anchor around our system's neck. And then finally, how do you present and use it? I will immediately say this is the bit I know least about. I'm not very good at visualization, my slides being exhibit 1. And I don't know a great deal about interacting with human beings in order to present information. There are lots of people who do, and I have a good book for you at the end, which I've learned quite a lot from. But the thing is that how many of you have seen a system dashboard where you really had no idea what it was trying to communicate to you? It's covered in graphs, it had alarms all over it, and down the right-hand side there was some stuff in red that looked vaguely worrying, and you really had no idea whether you should be worried or not. That's quite common, I've noticed, in dashboarding of all sorts. I'm not going to mention any particular tools, Jira, but there are quite a few tools that encourage impenetrable dashboards. So actually, how to present and use it sounds easy. I think it's quite difficult. And I think perhaps some of you may be great at it, but speaking for myself, many architects are not very well qualified on that bit. But it's important we bear it in mind, because if we don't have the right environment to visualize and present, we don't have the right data go into it, people who know about that still can't help us. So the concerns are pretty straightforward. In a sense, measurement's not terribly difficult to many other qualities. What do they need? How are we going to do it technically? And then, in this case, how do we present it? So what are the specific tactics? Well, I came up with quite a lot of tactics. I read some books, looked at blogs, very nice Amazon blog I'll tell you about in a bit, about dashboards, for example, talked to some people, and I came up with quite a few. Now, you will be relieved to hear, I think there's 12 on the slide. I'm only going to tell you about 3, but I'll very quickly go through them. So when we were trying to work out what to measure, this is classic architecture, classic stakeholder stuff. Who's going to use this, and what are they trying to do with it? And then, what metrics do they need? That's difficult. And I have a practical solution for you on that, which I don't know if you've met it or not, GQM, but I hadn't about a year ago. And then a guy called Michael Keeling, who I think has been to this conference, he's the author of Design It, and also did a chapter for the metrics book about GQM. He's used it a lot, and actually I think it works really well. So it's a structured approach to how you go from, I need to answer some questions, to here's exactly the metrics you need. We need to define metrics clearly. I know that sounds obvious, but how do you define a metric? What are the dimensions of a metric? I've got some thoughts on that. Oh, clearly, many people in the world have defined metrics, but it's interesting how many blog posts, books, conference talks on measurement and metrics I watched and scanned through, and none of them told you how to define a metric clearly. I've pitched it, I've sort of stolen the best bits and put them together, but I was quite surprised. But that doesn't seem to be something that just everybody knows. And then finally, another tactic is make sure you're considering internal and external views of the system, and both your operational metrics, how does the system work, but also the artifact metrics. What are we producing, and how well are we producing it? So that's the what. The how, there's an awful lot of bits of technology, and they can be plugged together in many ways. So a reference model is a really useful thing to organize the approach. I'll mention that in a minute again. Then I have seen a lot of teams over the years create their own mechanisms for metrics collection, sorting, filtering, transport, storage. All of it exists, I have now discovered. So I think an important tactic is use proven mechanism, unless there's a really good reason not to. And related to that, use interoperable protocols. Because again, people, I've noticed, particularly with measurement, because it's seen as quite tactical, not very architectural, there's an awful lot of custom formats, custom transports are used to move stuff around. And obviously Ben Evans is going to talk about OpenTelemetry just after this, so that's a very good example of it. And then finally, something which Neil talked about on Monday, and I think, Monday, yes. I think that's the first time I've really seen that brought to life is, measurements are pretty passive. And what happens, for example, who's got SonarCube? Nobody? Or who's got a measurement tool in their pipeline that produces output on dashboards? And after that, how many of you are convinced that those dashboards are driving change? Maybe a few less, yeah? And I think that's because the measurements, metrics, dashboard, they're all totally passive. Whereas the great thing about fitness functions is they're like database triggers, if you go back to a previous era. They're active. When something changes or goes wrong or is considered to be incorrect, they actively prompt you to do something. So they're a very useful tactic too. And then how to present, as I say, I know much less about this, but what I've learned is that you need specific presentation for specific people. That's why so many of those big dashboards don't work, because they're trying to create a dashboard for everyone. There's a very good blog written by somebody in system monitoring, actually, at AWS, that talks about all the dashboarding they use. And one of the things they stress is that for any service, they've got a large number of dashboards. For that very reason, because they tried creating one big dashboard over the years, and people just didn't know what to do with them. So now they create dashboards oriented towards less technical users, dashboards oriented towards engineers actually debugging the thing, dashboards oriented towards product, dashboards oriented towards themselves, the SRE type people, and that they've had terrific benefit from. Consistent presentation. Does red mean danger, or does red mean surprise, everything's good? Use existing styles wherever possible. That's the tip that all UX people will give you. Use familiar cues. In an organization, use the style guide. And again, use existing frameworks where possible. Don't start with a JavaScript framework when you can start with Grafana. And make UI self-describing with built-in documentation. Why do you think that's a good idea for measurement? Well, the primary reason is because people don't use these dashboards every day. In fact, they use them quite intermittently. And what happens to people's memory between June and the end of July? It fades. So a self-describing dashboard where you can build the documentation into it really helps people use them without having to make a load of phone calls, get on Slack or whatever else. The three things I just want to discuss in a bit more detail are using GQM, because just a show of hands, who uses goal question metric already? Yeah, 1, 2, yeah, 3. Yeah, I don't think it's very widely used, and I think it's a really good technique to work out what to measure and why it's valuable. Secondly, how do you define metrics clearly? To my surprise, that did not appear to be something that everybody was agreed on. And then the third thing is use a reference model to organize the approach. And that means really to organize the technology. Goal question metrics, that's an architectural tactic. Apply goal question metric. It's quite old, actually. You can see from the reference at the bottom of the slide, it's sort of 1984 it emerged. But I'm not sure it's had a lot of coverage, even in academia. I did an industrial PhD over about 10 years, finished a few years ago. I hadn't come across, and there was quite a lot of measurement in it, and I didn't come across GQM then. The thing about it is, it's really simple, it's highly collaborative, and it focuses attention on the value of the metrics that you want to collect. And I haven't seen another technique that really does that. It's very straightforward as a technique. You work as a team, you find the people who care, you get them to write a statement clearly stating what is it they want to understand. You then brainstorm with them to identify good questions that they might want to ask to give them insight into that goal. That needs quite a bit of iteration, because often people like product managers, or even perhaps the ops team, may not actually ask terribly insightful questions. But you just use a workshop format, you keep iterating, you get to the point where these appear to be interesting questions that actually give us good insight into whether we're meeting our goal. And then from there you go, right, well, what could we measure that allows you to answer that question? And then you organize them into a tree. It really is that straightforward. This one's a bit artificial because it has to fit on a slide. So therefore, one, it's quite simple, and two, there's not many words, so it's a bit cryptic. But you get the idea. We want to understand our request processing capacity because we want to predict future needs. Therefore, here's some questions we're going to ask. They're all a bit simplistic, but they fit in a small box. And then for those questions, fairly obviously, here's the measurements we want to make. Here's the metrics. And why would we bother doing this? Why don't we just start with the questions? Well, there's two reasons. One, because if we start with the why don't we start with the metrics. If we start with the metrics, we don't really know if they're valuable or not. We can collect an awful lot of metrics which are not valuable. And I see this quite a lot. People collect a lot of stuff which is easy to collect, and it's not clear that anyone is ever going to get any insight from it. So if we start at the other end, and we try and figure out the goal or what they're really trying to do, it's sort of standard stuff, right? Start with the requirements. Only in measurement, it seems we often don't. So if we start with the requirement, then work out the questions, then the metrics, that's useful because it focuses in on stuff that's valuable. And this technique allows you to work out what the most valuable thing to do is, rather than just picking the first things that come into people's mind. But the thing that's really useful is that you can see which metrics are valuable for many reasons, because these trees can all intermesh. The minimum, maximum, average CPU in a period may be useful for answering many questions, which may be for many goals. So you can see which ones are really high priority and very useful and valuable. And the other thing is that later on, if you're measuring something and you're having problems with the measurement, you immediately know where to go to find out, is this valuable? You go back to the question and go back to the goals. And you work out, actually, for this goal, this is not valuable enough to take up the amount of engineering time that we're currently using. So GQM is a kind of simple but structured technique which allows us to work out who wants to measure what, and most importantly, why. Once we've identified the metrics we want, we've then got to work out what they really mean. My experience with this over some period in different contexts is that actually product owners, end users, even sometimes engineers, may or may not be good at this. It seems to depend partly on the people as to whether they've got a fairly quantitative, perhaps, frame of mind, and whether they've got any experience with measurement themselves. But we need to obviously give it a name. We need to give it a description. But then it gets a bit more interesting. We need to record somewhere why it's being measured. That can obviously point to our goal question metric tree, but it's also useful to simply record it in our definition. Most importantly, or one of the most important things is, what are the units we're collecting it in? How many times have you gone into a database which is full of performance metrics, looked at a column and said, it'd be really useful to know if that was seconds or milliseconds right about now? Or storage for databases, when you went, wonder if that's megabytes or gigabytes. Makes quite a big difference at this point. And it's very, very common. You find databases full of measurements without any units. So if you're not getting metadata, you're a bit stuffed. Then what characteristics does it need? Does everything need to be of the same accuracy, how close it is to reality? Does everything need to be the same precision, that is, how repeatable is the measurement? Does everything need to be at the same resolution, like nanoseconds for time, or quarter of a cent for financial amounts? The answer is almost certainly not. We can almost, and the reason we ask these questions is because we can almost certainly collect something with low resolution, adequate accuracy, and adequate precision much more cheaply and much more quickly than something that has to have very high fidelity. So it's important we understand that. And finally, where is it coming from? This is where it meets reality. Have we got a data source for it? Because if we haven't, there's little point going any further. In fact, we kind of need to validate that a bit earlier, actually, when we're in the GQM step. That's part of the GQM workshop. But how do you actually measure this? Where do you get the data? And are there any calculations involved? Because after all, calculations tend to add significant complications. So we've said, here's what we'd like to measure, and we've got some justification as to why. We've defined our metrics now to a level where actually we can be fairly confident we understand them, and we understand the constraints that will be on us as we collect them. How might we start collecting them? Well, when I looked at the technology involved, as we saw from the logo screen, there's an awful lot of technology you can use for collection. You may not make sense to use it in your system. There's an awful lot of it. An awful lot of it does similar but not quite the same jobs. So when I thought about this, I did a bit of reading around. There's a guy called James Turnbull. He's got a book that's quite well known, The Art of Monitoring. And this is loosely based on a reference model he came up with. It's a little bit different. But the things you fundamentally need to do is, you need to have something that will take measurements. So you need to measure. You need to collect stuff reliably and move it around. You may need to pre-process it and derive from it. For example, in high-volume metric systems, it's quite common that you want to drop a lot of the original metrics and keep derived metrics. So for example, you might use a stream processor, or you might have something much more basic, such as something in your ETL loader, which simply puts summaries into your database. You need a reliable store. And of course, for metrics, what's the big complication with the store? It often has to be highly dimensional. It has to be time series. So perhaps MySQL would do the job, but actually for large metric stores or complex stores of a lot of measurements, perhaps that won't work. You might need a time series database, of which there are a number now. And finally, you need to visualize and present it. That's the bit where I stop talking, really. You need to visualize and present it, and there's lots of ways of doing that. So then when I thought about, okay, well, what would this look like in practice? To be clear, this is a reference model. This isn't an actual design of a specific system. This is the bits I think you need. So I do have a key, just to be clear, notation key, has just come up a couple of times this week. All the stuff in orange is the stuff that you may well need in order to do measurement effectively, and the blue stuff is real life. It's our SDLC tools and our code and our pipeline and our operational system. The things that I think you need are, you need metrics collectors that can collect both business measurements and also operational measurements from your operational system. You need collectors that will be in your pipeline. You need collectors from your SDLC tools. And you probably need fitness functions on some of those for critical things where it makes a big difference if they go out of some kind of desired range or tolerance. You clearly need some way to move the stuff around, so that's some kind of transport. You may need pre-processing and derivation. I actually, in the systems I've looked at, I've not come across that being all that important, but I did observe that when I read about the hyperscalers, they do a lot of stream processing on their measurements after they've taken them. And then you need the measurement store, and you need to be able to present it and visualize it, so you need a bit to do that. And finally, it's going to be very useful if we have a machine-readable definition of our metrics, because that's going to allow us to, for example, use metadata to drive some of this, and it's going to allow us to build in much more intelligent user interfaces with an awful lot less manual configuration of them if we know what the metric definitions are. So how would we use this? This is only a reference model. This is entirely theoretical. These are the bits you need. So you'll need one of those and maybe one of those. It's one of those models. Well, if you looked at a really, really simple measurement system, say we've got a small application and we are using quite primitive monitoring at this stage. It's not very complicated, and failure isn't going to be a huge problem. So we've got Zabbix. That's clearly a metrics collector. We might be looking for certain things in our log files. We've written ourselves a log scraper. It's that simple. We've got something that collects our business metrics from the database. We shovel all that into MySQL. We've also got some stuff in our pipeline. We're not blind to the fact that we need to measure what we're doing, as well as the operational system. And maybe we're unloading some information from Jira, using quite primitive tools to stick it into MySQL. And then we're not really using our metrics definitions in code. The dashed lines, if you remember, mean it's a dependency. We're just using some simple stuff in Grafana and maybe some Excel to analyze it. So what? Well, the interesting thing is, if we overlay it, which doesn't come up terribly well on the screen, those are meant to be light gray, the bits from our reference model are all there, apart from derivation. So we've got collectors, and we've got fitness functions. We've got a transport system. It's pretty primitive, but we have got a transport system. And we've clearly got presentation and visualization. And we've clearly got metric definitions. And for a system this simple, that's all pretty self-evident. Doesn't really make very much difference to us. But if we went to a more complicated model, we'd be able to say the same things about it. And so if we had to evolve from a very simple system to a much more complicated one, we'd still be quite clear what pieces we had in our measurement system and why they were there. And the interesting thing, of course, is the real technology doesn't always fit the reference model perfectly. So in this case, we've got a much more sophisticated pipeline, though as it happens, we're still collecting measurements in a file, and we're using Prometheus, because everyone uses Prometheus. We're using the node exporter to move the files around. The operational system's using OpenTelemetry to collect lots of internal measures, probably business measures coming straight out of OpenTelemetry. We're still pulling stuff out of the database. We're using Grafana with a custom plugin to read our metrics definitions and create a much more sophisticated dynamic dashboard. It's quite different to that one, isn't it, really? I mean, it's dramatically different. It's a much higher end monitoring, management, measurement infrastructure. I got the right word in the end. The important thing is that it's got all the same pieces from an architectural perspective. And the reason this is useful is because it allows us to reason on how we'd get from here to there, and what all the bits, the measuring bits in here actually do. And that's useful because when you go in and look at systems, especially stuff that wasn't thought about as first-class architectural, you typically find quite a lot of quite complicated technology has been bolted around the edges. And when you ask deeply searching questions such as, what does that do? There's often a bit of a pause and people go, well, it's to do with metrics stuff. And is it collecting or is it storing or, I probably have to go and ask someone. And it's not that the people aren't interested, it's more that this has never been seen as very important. Whereas as soon as we sort of make it architectural, we have a reference model to map it all to, we now know what the bits do, we know why they're there, and when somebody turns up and says, here's a new visualization thing, you go, okay, well it fits in the box along with that one, we've now got two. Are you quite clear you want two? As opposed to what normally happens is, that's a nice idea, let's plug that in and see how it works. What is an interesting tiny detail is that, as I said, the real world doesn't match the reference model, and that's fine, because the reference model still gives us a framework to think about what we've got on the system. And so in particular, Prometheus is a measurement store and also preprocessor, and it can do derivations, so it's query language. Some things are collectors, but some things are collectors and transporters. And that's fine, because the reference model tells us what pieces we need, and we mentally map those functions, those conceptual components, onto the actual technical ones we've got, and we know what they're doing. In this case, suppose you wanted to change your metrics transport because it was now becoming very high volume, or you wanted to put stream processing in it. What can you immediately infer from using the reference model? You've got quite a big problem, because the collectors do collection and transport. And so you're going to have to figure out how you work around that real-world architectural reality while trying to replace one thing in your reference model. The other thing we could do for people is we can give them activities. I won't go through this in detail because we've sort of talked through it, really. The reason in an architectural perspective we write down a simple activity diagram is we've given people a load of tactics. We've said, here's lots of stuff you should go and do, especially for people who haven't met it before, or for that matter, you, when you haven't done it for 3 years and you have to go back and do it on a new system, it can be quite difficult to figure out what to do when. So an idealized activity diagram is a useful aid memoir, teaching aid, and just a reference to pass on architectural knowledge to other people. So in this case, it's like many quality attribute activities. We work out the requirements, we work out solutions, we then use them, and then we go into sort of an inner loop of using them, and we can continually validate whether they're fit for purpose, and if not, we go back and start challenging our assumptions and making the changes that we need to do. So then that leaves us to the inevitable pitfalls. Things do go wrong, and I don't know of any group of people who are better at working out what goes wrong on a regular basis than architects. The pitfalls I have observed, and that other people have observed in the research I've done, are, the first one is very similar to security. So until recently, I did a lot of security talks about application security. I did it when it was unfashionable, and now it's deeply fashionable, so I've stopped doing it, because everyone else is doing security talks, which is brilliant. But this immediately resonated with my experience from security, which was, what's the first thing most people do when they think about system security? And in fact, if you say to people, is your system secure? What's one of the answers developers often give you? Yes, we're using Spring Security and SSL. Okay, TLS. That wasn't quite the question I asked. You've just told me what security mechanisms you're using. And this nearly always happens. I see it again and again and again with clients we work with. I'll go in and ask some questions about security, and they will not answer those questions. They'll tell me what security technology they're using. They don't know what threats they're facing. So in other words, the risks. They're not sure what security they need, but they have started selecting security technology. This seems to happen a lot with measurement as well, which is, we've got some stuff that could measure, so therefore we should implement that stuff, rather than worrying about what it is we have to measure. As we said, one of the big problems is not quite knowing what goals we need to hit when we start the whole measurement program. The related thing is, people want to measure what's easy to measure. That's very, very human, isn't it? Who doesn't love a good quick win? Everybody loves a quick win. So you measure a load of stuff that's easy to measure. Actually, if you've put in some measurement infrastructure, I think measuring what's easy to measure as like a step 0 is a really smart thing to do. Because you prove your infrastructure works, and you get people's imaginations running. Oh, we could do this. And you can visualize all those things together, and you can derive rates of change. Oh, and you can put alerts on. Oh, that's all very useful. I've got all new kinds of ideas what I might want to measure now. That's a great first step, but clearly, if we're measuring a load of stuff that's easy to measure, it may or may not actually be valuable. You also get people who may be measuring stuff that appears to be valuable, but it's actually being measured without a specific purpose. And it's often based on experience. We have tended to find this is quite useful to measure historically. That's probably, again, not a bad starting point, but without knowing what the goal is, the problem is, this, I think, is where the big bloated measurement databases come from. You see this quite a lot. People have got a good measurement infrastructure in place and a massive database full of numbers that nobody quite understands. It's because they're measuring a whole lot of stuff that could well be valuable someday to someone, but without a specific goal. So you end up just measuring too much stuff that all needs to be managed. As engineers, we tend to focus on technical metrics rather than business metrics. Who looks forward to their primary interaction being with product? There must be somebody who loves product. Normally, we rather work, we are more comfortable working with technical stakeholders. So there is a natural bias towards measure, and of course, measurement is quite a technical business. There's a natural bias towards measuring stuff that's technical, and that's fine for some people. It's not going to answer all the questions that need to be answered. For example, delivery management are possibly not going to be as interested in that as in SDLC type measurements. And finally, prioritizing accuracy over usefulness. And this is where we're trying to measure things absolutely correctly, and that is laudable, because if you don't hit the accuracy threshold, clearly you're either misleading people or you're giving them very partial information. So it's good to meet the accuracy threshold, but you also see people prioritizing accuracy over a measurement that is useful to meet a goal. And again, I see that quite commonly. It's because people can. And the last one's not really a pitfall to do with architecture, or measurement. It's simply human nature. How many of you do sprint retrospectives? Quite a few. How many of you confidently action all the outputs of the sprint retrospectives? Yeah, good. There are some hands up. That's actually really good, because I think it's quite a common problem. And it's exactly the same problem. It's not taking action based on what we know. And you could argue a sprint retrospective is a form of feedback loop, of course, though it's probably not a technical measurement one. But clearly the problem here is we've wasted quite a lot of time and money. We've burdened our system with some measurement mechanisms that don't look as if they're very useful. And honestly, people who are involved in this are not going to be very motivated next time somebody asks them to measure something. So it's kind of an obvious thing, but actually we need to, as architects, we're in a good position to make a bit of an assessment of that quite early. Is this really going to be used to drive behavior, or is it a bit of a vanity metric that perhaps we should argue isn't that important? So, feedback is important in nearly all modern delivery approaches for software. Feedback, regrettably, needs measurement. And I've observed that measurement is quite complicated, and quite a lot of projects get into a bit of a tangle with measurement, either because they start out very small and then it suddenly grows, or simply because aspects of their measurement are quite difficult to do, but it's always a side project. No one ever puts it on the backlog properly. The architecture team or the technical leads never really view it as an important system quality, and it ends up always being the quickest thing possible and ends up being a bit of a mess, which ends up being a nasty bit of the system. If we treat it as a quality attribute, it helps focus attention on it. And so that helps us prioritize it, think about how to integrate it into the rest of our work, explain it to other people as to why it's important, and also we can focus on whether we've got reusable knowledge that helps us do it well. An architectural perspective is a way of sharing knowledge about any quality attribute. If you go to that website, there are various perspectives there already, and it reminds us what the concerns for that quality are, what tactics we've got in our toolbox to meet those concerns, what activities we should remember to do, and perhaps even roughly in what order, in order to address the quality attribute, and what's going to go wrong, or what has tended to go wrong historically, that we should avoid on our own projects. We tend to summarize perspectives in these rather dense tables, but the things that I think are worth taking away is that measurement is worth taking seriously. It gets complicated faster than anyone expects, and therefore comes back to bite us. It's often difficult to know what we should be measuring and what's got value to who. So a technique like goal, question, metric, or indeed how to measure anything, though actually I think goal, question, metric is much simpler, and I certainly related to it far quicker. When we're thinking about how to measure and what technology we need to measure, there's a lot of options and a lot of moving parts. If we have a reference model, and my reference model may not be the right one, but it's a first step towards one, using a reference model helps us remember what the parts we need are, how they relate to each other, and so what every bit of the technical puzzle is doing. And we need to remember to visualize for the audience and for the specific goal. And there will be some pitfalls. I've identified some that I have observed, and I think other people have observed. We've probably missed some, so let me know about the other ones that you're aware of. To find out more, the couple of books which I just mentioned would be, there's the Software Architecture Metrics book. That's really a collection of essays, but there's a number of people talk about measurement in there. The How to Measure Anything book I mentioned, that's quite interesting because it's got a very, I suppose you could say, a very businessy approach to measurement inside business and organizations, which might be very good for communicating with business stakeholders. The one I mentioned about data visualization that I know almost nothing about is actually an O'Reilly book. The guy who wrote it is something like an evolutionary biologist, or he's a scientist anyway, in one of the American universities, and he's written a very nice book on how you visualize data. It's not about how you do dashboards for software. It's about general data visualization. But one really good thing in it is he's got a catalog which says, if you've got this sort of data and this sort of problem, use these sorts of visualizations, which for a visualization idiot like myself is very useful. And then, of course, evolutionary architectures, which has come up a few times. On the back, very briefly, software systems architecture is where the perspective idea came from, and there's a number of perspectives in that. And then the continuous architecture approach is the one that stresses feedback, and the importance of feedback loops just doesn't tell you all that much about creating them. And Michael Keeling's book, Design It, is on the end there. It's a great book, actually, for introducing teams to design and architecture topics. But I mention it specifically because he has a chapter on goal, question, metric, and how he's used it with software teams to help them identify good goals, do good measurement, and move towards those goals. Once again, thank you to our sponsors, and of course also to our supporters who also made a contribution to the event. Thank you very much. I'm happy to take any questions.
Thank you so much. We already have our first questions. So, when defining and measuring a metric, how would one prevent optimizing for the metric versus the overarching goal?
Just find the session. No.
The first one that appears.
Can you repeat it? Sorry,
sure.
My phone isn't connected.
When defining and measuring a metric, how would one prevent optimizing for the metric versus the overarching goal?
Oh, that's a great question, yes. So you've got a goal, you've got some interesting questions, you've got a bunch of specific metrics, things you want to measure. How do you avoid optimizing for one of the metrics? Yeah, great question. I think the key thing is to keep people focused on why the metric is there and the fact that they're going to have to measure other things in order to get to the understanding their goal. So you as ultimate trade-off type person, because you're an architect, you're very well placed to keep reminding them of that and making sure that they trade off between obsessing about one as opposed to measuring all the things they have to measure.
I'll come here like this. You don't need to go back and forth. Okay, so the next question is how to keep your metrics and, more importantly, presentation of results simple.
Yeah, I think, so I mentioned that AWS have a blog. Ping me afterwards if you want the URL. I don't have it to hand. But they stress, now that's for technical stakeholders, but they stress the importance of different presentations for different people. And I think that's key to keeping it simple. I think the reason they become complicated is we're trying to serve different purposes with one visualization. And to avoid that, I think, don't be afraid to create multiple visualizations. Even perhaps for one role rather than person, one role that actually is trying to work out different things. I think smaller focused visualizations work better than the big kind of single pane of glass style ones that people seem to like, actually. But I think the problem with them is they're trying to be all things to all people, so they don't serve anyone very well.
Thank you. And then any recommendation on the strategy to monitor the monitoring system, for example, availability of the Prometheus?
Yeah, so how do you monitor a monitoring system? My honest answer, I think, is ask an SRE engineer. I don't know a great deal about that. There are a few principles which are very well known in the industry, such as the monitoring system has to be extremely simple, it has to be one that can be restarted very fast, and it has to be one that is very conservative in all of its design decisions, so it's reliable as possible. But honestly, SRE is not my subject, so I would refer you to learned colleagues of mine who put in monitoring systems on a regular basis, or perhaps Ben, who might know about that.
And last question for the session. What is the difference between a metric and a fitness function?
Oh, right, yes. So a metric is, so a metric is something you want to measure, a definition of it. A measurement is making an observation of that. A fitness function is a condition that you want to monitor for. So measurements, I've got it wrong myself there. Measurements are great inputs to fitness functions, and they can make fitness functions much simpler than the fitness function where you have to go and gather all the data in the fitness function, and that makes the fitness function quite difficult. If you've got infrastructure in place that can derive good streams of reliable measurements, then fitness functions can wrap around those much more easily than starting from scratch. So the fitness function is, if you like, the monitor. It's the if statement that checks whether that measurement is within tolerable bounds or has exceeded a limit or whatever.
Thank you so much. And we continue with other questions in the Q&A session.
Of course.
Tonight, right? Thank you.
Thank you.